operations. So we did addition, subtraction, and multiplication. However, we didn't do any division, and that's because division is a little bit different than some of our other operations. So today, we're going to look at the first type of polynomial division. So, there are a couple of different cases of polynomial division. The first is when we take a polynomial or a trinomial or a binomial, anything that's bigger than a monomial, and divide it by a monomial. And this is a pretty specific case, and the reason why it's a specific case is because what we can do is just take each of the terms in the numerator and divide them each separately by the denominator. So we're just going to break it apart into, in this case, 3 separate fractions. So we would have 6x to the 4th y to the 3rd divided by 3xy plus 12x cubed y squared divided by 3xy minus 18x squared y divided by 3xy. And then we would just need to do our normal division that we talked about with our exponent rules in our last lesson. So remember, we want to take care of our numbers first. So we would have 6 divided by 3 gives us 2. Then we're dividing, so we would subtract our exponents. So x to the 4th, so we have 4 minus x to the 1st, so minus 1. We get x to the 3rd. Then we have y cubed divided by y, so we're going to get y squared. And then our next term is 12 divided by 3, so we get 4. Then we have x cubed divided by x, so we get x squared. And then we have y squared divided by y, so we get y. So then our last term, it's going to be negative. So we have 18 divided by 3, so we get 6. X squared divided by x gives us x, and then y divided by y is just 1, so we don't need to write that. So then we need to decide if we have any like terms, and remember that for them to be like terms, I have to have exactly the same exponents and variables. So on our first two, we have x's and y's, but notice that they don't have the same exponents. And then on our last one, we don't even have y's. So none of them have exactly the same exponents and variables. So we can't combine anything. So that is our final answer. So that is one type of polynomial division, and that's when we're dividing by a monomial, or just one term in the denominator. And in that case, we'll go ahead and just break it apart into however many fractions we need. Now, that is not how we're going to do most of our divisions. So let's think all the way back to like pre-algebra, 5th grade, 6th grade math class, when we first learned about long division. So hopefully we vaguely remember just normal number long division. So remember that we have a division bar. The number that goes on the outside is going to be the divisor. The number that you're dividing by is your dividend. When I'm teaching this to some of our younger kids, I like to say that it's inside the little den or the house. So that's why it's called our dividend. Okay, and then lastly, remember that our answer, or what goes on top, is going to be our quotient. So in this case, we're dividing 643 by 5. So 643 is our dividend. 5 is our divisor, so that's what goes on the outside. So then remember that our first step is to say, how many times does 5 go into our first number, which is 6? It goes into it 1 time. So then we multiply. 1 times 5 gives us 5, and then we subtract as we go down. So we get 1. Next, we bring down our 4, and we start the process over again. So I say, how many times does 5 go into 14? That's going to be 2 times. And we get 10. Again, we're going to subtract as we go down. So we get 4. Bring down our next number. We get 3. And now we say, how many times does 5 go into 43? That's going to be 8. 8 times 5 gives us 40. We subtract and we get 3. 5 can't go into 3. So you have 2 options at this point. One is we're just going to box this off and say that we have a remainder of 3. The other option is that you can start adding zeros to find the decimal for this number, but we're just going to stick with the remainder. So we would say that our answer, or our quotient, so 643 divided by 5, is going to be 128 with a remainder of 3. Now remember that the other way that you can write this, so 643 divided by 5 is an improper fraction. So once we know what our quotient is, or basically how many times it goes into it evenly, we can write this as a mixed number instead and say that this is 128 and 3/5. And the reason I write it like that is because when we start doing our polynomial division, we're going to write some of our answers like that as well. Now, the reason that we review this is because when we start our division for polynomials, the process is going to be very similar. We do have to make sure of a couple of things first. So we need to make sure that both the divisor and dividend are in descending order by the exponents. What that means is that we have to have like to the third, to the second, to the first, and then our constant, they need to start from the biggest exponent and then go down to our smallest exponent. And then the other key thing that we need to look at is that all terms must be present. Which means that if we start with a third power and then we skip to, say, a first power, we're going to have to add placeholders of 0 for missing terms. So let's go ahead and look at this first example. So it says use long division to find x squared plus 3x minus 40 divided by x minus 5. So first off, we need to make sure that both of them are descending order. So notice that we go from x squared to 3x to 40. So those are in descending order. And then we go from x to 5. So that's also in descending order. And then we start at x squared, go to x, and then our constant for our dividend. And then our divisor goes from x to a constant. So we don't have any missing terms either. So we can go ahead and just set up our division. It's the same type of division bar that we had for our normal number. Our dividend goes on the inside, so remember that that is what we're dividing into. So we put the x squared plus 3x minus 40 on the inside, and the x minus 5 is what goes on the outside. And so our process is going to be very similar. I want to just really focus on my x. And so my first process, or what I'm looking at, is I'm saying, okay, what do I need to multiply x by to get x squared? Well, I would need to multiply x by x in order to get x squared. And so then as we come down, we're going to multiply. So we would have x squared, and then we have x times a negative 5 gives us a negative 5x. And then just like with our other long division, I'm going to subtract as I come down. So I have x squared minus x squared, and so I get 0. And this 0 is really important. I always have to get 0 for my first terms that I subtract. If I don't get 0, that either means 1, I picked the wrong thing on top, or we multiplied incorrectly. But we always need those first terms to go away. And then I'm going to subtract the next two terms. So I have 3x minus negative 5x. And I am still subtracting, so be careful with that, because we're going to end up with an 8x because we're subtracting a negative. So then our next step, just like with our number division, is going to bring down our next number. And then basically, just like before, we start that whole process over again. So I'm going to say, what do I need to multiply x by to get 8x? Well, we would have to multiply that by an 8. And then we do our multiplication again. So 8 times x gives us an 8x. And then 8 times negative 5 gives us negative 40. Again, we are subtracting as we go down. 8x minus 8x is 0, which is what we have to get. And then negative 40 minus a negative 40, so that's going to become negative 40 plus 40, which gives us 0. And just like before, that last number that you get there is going to be our remainder. So in this case, we don't have a remainder, so our answer is just going to be x plus 8. So let's go ahead and look at another example. So it says, which expression is equal to a squared plus 7a minus 11 times 3 minus 8 to the negative first? Well, to start off with, it's a multiple choice question, so we do have some options for our answers this time. And off the bat, it doesn't quite look like a division problem. However, remember that we can rewrite that negative exponent as a fraction. So remember from our first lesson that when we have something that is raised to a negative exponent, that's going to be the same as rewriting it in the denominator of the fraction. So again, remember that we need to check a couple of things. First, we need them to be in descending order by exponent. And our numerator is okay, but notice that our denominator starts with our constant term and then goes to our first term. So that is not in descending order. So we need to rewrite that in descending order. So instead, we're going to rewrite it as negative a plus 3. Again, we don't have any missing terms, so we don't have to put any placeholders in. So same process that we had before. I'm going to put my dividend on the inside, my divisor on the outside, and then we're going to do our long division. So we're going to say negative a times what is going to give us a squared. So that would be a negative a. Negative a times negative a gives us a positive a squared. Negative a times 3 gives us a negative 3a. I'm going to subtract as I come down, so we get 0, which is what we need. And then 7a minus a negative 3a is going to turn to addition, so we get 10a. Next, we bring down our negative 11, and then we start the process over again. So we say negative a times what gives us that 10a. It's going to be a negative 10. So we know right now that our answer is going to be either C or D. But we need to find our remainder to figure out which one of those it is. So then we do negative 10 times negative a is going to give us a positive 10a. Negative 10 times 3 is going to give us a negative 30. And then we're going to subtract as we go down. So because the 30 is negative, it's going to end up being addition. So it would be negative 11 minus a negative 30. So it would be negative 11 plus 30, which gives us 19. So positive 19 is going to be our remainder. So notice that we could rewrite this as negative a minus 10 with a remainder of 19. Now remember back to when I talked about that there's the other way that we can rewrite this is kind of like it's a mixed number. So remember with our first example, we got that 128 as our whole number. So that went off by itself. And then we had and then we had the fraction. Well, if we think about it, and is just another way of saying we're adding. We're adding an extra fraction. So we're going to go ahead and add an extra fraction. And so remember last time, it's your remainder is what goes on top of that fraction. So 19 divided by our original divisor, which is 3 minus a. So notice that if we look at the top, that is going to be answer